In this video, we're going to look at electromagnetism, which is the relationship between electricity and magnetism. And we've already actually seen a bit about this. If you remember back in Unit 2, we looked at Faraday's law and electromagnetic induction. And electromagnetic induction is just relating electricity and magnetism. It says that they're connected, and specifically a change in one creates the other. So we mainly looked at how if you change the magnetic field, you create a current, you create electricity. But we also have the kind of inverse, where you can change the electricity and create a magnetic field. So a current traveling through a wire creates a magnetic field. And this is going to obey magnetic field. And this is going to obey the right-hand rule. And so what that means, it's a convention that we have in physics that we always use our right hand. And I think I'm checking my monitor to see if this is going to look proper to you. So my thumb is pointing to, I think this works out. Yeah. So this is my right hand. The problem is if this ends up looking like my left hand, then you're going to have a problem understanding what I'm talking about. But we look at the right hand rule, means you point your thumb in the direction of the current, and then your fingers wrap around the wire in the direction of the magnetic field, because it creates a magnetic field in a circle around that wire. So if this is my wire, my pen is my wire, and the current is flowing from the bottom to the top, I place my thumb in the same direction, and then my hand wraps around the wire, and that means the electric or the magnetic field goes around like this. So I'll illustrate that here. If I have a current traveling like this through the wire, we'd point our thumb upwards and diagonally, which I guess would look like this to you, and then wrap our fingers around, and so it would come around the front, kind of front and down, and then back around the back. So it would come around the front like this, and then go around the back. Around the front like this, and then around the back. Around the front like this, and then around the back. And you can, pull out your own hand and test that out, kind of align it with the screen and see how it matches and get that idea. That means we can create a magnetic field just by sending current through a wire. Now, if we coil that wire, we create a solenoid. And so that would be looking something like this. Let me see how big I can draw it to make it clear. So imagine this coiled wire like this. And then the current, we'll say, is traveling through in that direction. And now, if I get a different color, we're going to draw the magnetic field. So at the bottom here, we have it curving, like that. Then here we have it curving like that. Here we have it curving like that. Like that. And am I drawing these wrong? I think that is backwards, so it should be like that. And then this wire that kind of comes out front will be around like this. Now what ends up happening, and you can kind of sketch this out or talk to me in class and we can kind of work through it together. What ends up happening is you get a net current through the center of the wire. So you get all of, or not net current, a net magnetic field. So you get all these magnetic fields lining up so that you get this big, strong magnetic field all the way through the center of that wire. Because they kind of, around the edges, they all pile in and point in the same direction. Did I draw this the right way? So that's around the back. No, it's backwards. Sorry, these arrows should be on the other side. And this is something that is a lot easier to show in person, so ask me in class if you're kind of confused on this. But the point is these all stack up and we get a really strong magnetic field through the center of that wire. And around the outsides and kind of other parts, it kind of can't, most of it ends up canceling out and we get very little. So what does that mean for us? Well, you've already learned about how magnets work as being little, you know, kind of this shape with a bunch of little regions in it. And those regions can kind of be aligned differently. So this is from that first video you watched here in the unit. So now what's cool about electromagnets is if you have a magnet like this, you can bring that coil of wire in and then turn it on, and you can set a specific region to have a given direction. So if you wanted this region down here that I'm looking at to point down, I could bring an electromagnetic in, point it in the right direction, turn the coil on, and I could get this to be pointed all down. And so you can imagine I can set all these different regions to point in different directions, and we'll see in our next lesson how that ends up being useful for storing data.